Hi guys and welcome back. And in the earlier video, we have learned how to run a Python program in Notepad with Anaconda prompt. However, Notepad is not a good text editor because it does not do the indentation and coloring for the keyword. So we've got a better text editor called Spider. If you have already installed Anaconda package following my earlier video, then the program called Spider would have been installed together. So let's click it by typing Spider on your search bar. Let's wait a bit till it loads. Once it has been loaded, it'll look like this. And to create a program, you can go to File on the top and click New File and go to File again, and down here click Save It, and you can go to the directory that you want to work on. In my case, I'll go to C drive and go to Prog folder, and in this directory I'll write my Python program. In this tutorial, we will be writing a program that converts the image into a vector that consists of pixel values for the original image. And let's write the program name as image read.py. The program name, it's good practice to write a name that can represent the task of your project. And the reason that we are converting the image into a vector that consists of numbers is because computers cannot understand the image directly. It can only understand the numbers. And the images are represented with pixel values that consist of RGB values. Each pixel value can be represented with a combination of red, green, and blue colors, and each color ranges from 0 to 255. So to read an image, let's type import cv2, and cv2 is a package that provides a function to read an image. And as we do not need temp.py, let's delete it and let's keep on. If you want to look the characters bigger, you can widen it by typing Ctrl plus plus, and let's press Ctrl and press plus while you are pressing the Control button on your keyboard. So you can press your plus button as many times as you want to make it bigger, and if you want to make it smaller, and you can replace plus with minus. So press minus while you are pressing the control button on your keyboard, and it will make the characters look smaller. So I am good with this big, so let's read an image. And there's something called comment, and if you type sharp and write something here, then when the program is compiled, then you ignore this line. And what compile means is that this program will be translated to a machine language that consists of binary numbers. And the reason that this um, original program must be translated to machine languages because, as I have said earlier, computers cannot understand human language. It can only understand numbers. So what the translating process is compiling. And mm, in case of Python, it is actually it is an interpreter rather than a compiler because it compiles each line and runs each line at the same time. So let's do not take too serious on that. So let's just remember that the program must be translated to machine language that consists of binary numbers to under so that to for the computers to understand the program that humans wrote. So to read the image, you can use the cbit to that image read, and there is a mm, there needs a directory identifier to store the directory where in which the image resides. So let's write image path, and for the let's go to the directory where the image is. Go to C drive and go to prog folder. And if you go to data, then here is an image of elephant. Let's write this directory path and store it to an identifier called image path. So type dot slash data, and what this dot means is it denotes the current working directory, and because our program image read.py is in this directory C drive prog and this data folder is in prog folder, so that represents the current directory where the image read.py program is. And then in data folder there's an image elephant.jpg, so let's copy this image name and slash and paste it. And if you read that image, you need an identifier to save that read image, and let's store it to an identifier with the name image, and you pass the argument image path to this function image read. And what argument means is the actual value to the parameter of the function. And there's a term called parameter. Parameter is an identifier that receives the argument to the function. And before we define each terms, let's think about what function is. If we got a function called y is equal if of x, and let's say if of x is defined as 2x plus 1, and let's say the argument to the function is 2, then the y value will be 5, and if the argument to the function is equal to 1, then the y value will be 2 times 1 plus 1 is equal to 3. And what this function returns is the result of the function. And if you look at this function definition, the x is the parameter because it is an identifier that receives the value to the function, and each value 2 or 1 is the argument to the function. So I guess you have understood the definition of the terms, argument, and parameter respectively. So let's keep on going and let's print how image looks like. So to compile this program and run this program, you can click this button here. If you click it, it will say module not found error. And this package CV2 is not automatically installed while you have installed the Anaconda package. So you need to install it explicitly. To install it explicitly, let's go to Anaconda prompt. And the command for installing CV2 package is pip install open cv hyphen python and press enter, and it says successfully installed. And let's go back to our spider and let's run this program again. Press this button, and if you go to on your right side, there's a console that shows the result of the image, and you'll see a bunch of pixel values here. And what this each value represents is the RGB value. And if you go to paint, let's go to paint and click edit colors and press color, and let's look at the RGB value. Then you can look red, green, blue, and each value ranges from 0 to 255. And actually color is a combination of these pixel values. So let's go back to our result, and each row corresponds to represents the color. So these three values represent red, green, and blue respectively, and they are stored in the position that represents the location of the image. So let's type the image shape, comma dot image dot shape, and it will print the image of the shape. And from now on, every time you write your program, it's a good practice that you write a comment that describes your code. And to write the comment, you can put prefix before your code, or you can put type double quotes 3 times and double quotes 3 times again, and within this two triple double quotes you can write your comments. So print the shape of the image. So once this program runs, then this Python program will ignore this line commented. So let's look at the shape of this image. And there's a shortcut for running your program. It's control, it's if and press 5. It's F5. So if you press F5, it will run this Python program. Here I'll run this program by pressing this button. And if you look at the result, you can see that the image shape is 426 by 640 by 3. So if it's got 3 axes, and let's look at the image and go to properties and go to details. And if you look at the details, you can see the width and height of the image, and the width is 640 and the height is 426. So if you double click this image, it means that it is this width is 426. Actually, the width is 640 and the height is 426. So to represent this image in vector space, it will be 426 by 640 by 3. It's because as the height is let's look at the details again. Let's write it down. The width is 640 and the height is 426. So because the height is 426, the first row will be 0 and the second row will be 1, and for the indexes it starts from 0, so 0 to it will have 0 to 425 rows. So the first dimension here is 426, and let's go back to look at the dimension, and because the width is 640 pixels, it will have 640 columns ranging from columns, the number of columns will be from 0 to 639. And looking at the image shape again, it's 426 by 640 by 3, and this 3 represents the pixel value, actually the color at that location. So for example, if we take image 3 by 4, then it will return an RGB value at this location 3 by 4, and this location represents the color value of this image at this location. So let's print out the pixel value for this location of this image. So let's go to print pixel value colon comma image 3 by 4. So let's press this and see the result. The pixel value is 252, 214, 172. And if you go to paint, let's edit colors to and right. What was the value? Let's look at it. 200, and let's write it down somewhere. Image 3 by 4. It's 252, 214, 172. Then if you go to paint, let's colors, edit colors. let's write 252, and for the green 214, 172, and this value looks color looks like this. And if we look at the image, um, mm, yeah, this color is somewhere in this image. So going back to our Python program, next let's show this image. To show the image from this vector, image vector, you can type cv2.imageShow and pass the name of the image as image and type image. And let's write this as elephant. Let's write the name of this image as elephant and press type cv2.wait key and 0 and compile again. Did we so if you compile this program, then an image looking like this will pop up. So this is the same image that we have looked at on the saved file. So up to this point, we have learned how to convert this image saved in a directory to a vector that composed of pixel values of this image, and how to convert this to back to image again from the um, vector image that is composed of pixel values. So I'll finish off here, and thanks for listening.